Hello students, welcome back to the 7th video of this playlist. So in this video, we will be solving question number 7 from January 2024 Pure Mathematics 2 paper. So let's see what's the question number 7 from this paper is about. Okay, so question number 7, the concepts behind question number 7, it's from a sequence and series that has been discussed in chapter number 5 of your Pure Mathematics 2 textbook. So in order to be able to solve this question, definitely you should have clear idea about sequences, series, the equations and the formulas that are used in sequence and series, or yeah, to be more specific, in uh, geometric and arithmetic progression. What are the formulas for summation and finding nth term? These formulas you should have idea about. Okay, so let's get started with question number 7. So wheat is grown on a farm. In year 1, the farm produced 300 tons of wheat. Okay, in year 12, year 1 is the first year, year 12 is the 12th year, the farm is predicted to produce 4,000 tons of wheat. Okay, Model A assumes that the amount of wheat produced on the farm will increase by the same amount each year. Okay, so the first model, that is model A, predicts that the amount of wheat, it will increase by the what? Same amount. If it increases by the same amount, it says same amount, not same rate. That means this model A is basically a an arithmetic progression, right? Okay, fine. So part A asks here to use model A to find the amount of wheat produced on the farm in year 4. Give you answer to the nearest 10 tons. In year 4, how much amount of uh, what wheat will be produced? We need to find out that. So the first term of this arithmetic progression is what? 300, right? 300. Okay, so in the first part A equals to what? 300. Okay, and common difference, not ratio. Common difference is what? We don't know the value for the common ratio. Sorry, common difference. So we need to find out the common difference at first. Okay, how can we find out? So in year 12, how much uh, weight has been produced? It's given. So we know the 12th term. Okay, so first term is 300, which corresponds to the first year. It means 12th year. This is how which term? This will be the 12th term, right? So 12th term is what? 12th term is what? A plus n minus 1. So 11d, right? So 300 plus 11d is equals to how much? 4,000, right? This is equals to 4,000. Okay. So value for d would be 4,000 minus 300 over 11. This is 3,700 over 11. This is the common difference. Okay, so this is 3,700 over 11. This is the common difference. So we need what? The amount of wheat produced in the 4th year, right? So 4th year will be 4th term. So 4th term is what? 300 plus n minus 1, that is 4 minus 1. This is 3 times d. 3,700 over 11. So how much is this? This will give you 3 times 3,700 over 11. plus 300. So this is basically 1309.0909, something like that. It keeps going. So they wanted to the nearest 10 tons, right? So 1310 what tons. Okay, and this is what uh, part A of question number 7 has asked for. Okay, next is part B. So for part B, model B assumes that the amount of wheat produced on the farm will increase by the same percentage each year. Same percentage. That means it will be increasing at a rate. That means it has a common ratio, isn't it? So B asks to use the model B to find the amount of wheat produced on the farm in year 2. In the second year, give your answer to the nearest 10 tons. Okay, earlier one was arithmetic progression. Now in part B, it is geometric progression. So for part B, same approach as part A. Fine. I hope you understand. So the first term is given as how much? It's 300. Okay. So we need to find out the common ratio. So 300 r to the power what? 12 term is 12 minus 1, right? This is 11. This is equals what? 4,000, right? 4,000 exactly. So r to the power 11. This is equals how much? 4,000 over 300. So 40 over 3. 40 over 3. So the value for r, it's what? 40 over 3 to the power 1 over 11. I keep it exact so that we can get the accurate value. Okay. Now, year 2. We wanted the amount produced in the year 2. So this is what? AR, right? So AR is what? Second term. So we got the value for R. So second term is what? AR, which is 300 times. What's the value for R? We got the value for R, which is 40 over 3 to the power 1 over 11. So, oh, this is R. So R to the power 1. So yeah, this is just R. Second term is R to the power A, R to the power n minus 1. So n is 2. So 2 minus 1 is what? Power is 1. So 40 over 3 to the power 1 over 11, this is 1.265 something. So times 300, it gives 379 point, 379.654, something like that. So we can round it to the nearest what? Tenths, right? So 300 what? 80 tons. That's the amount of weight produced, the predicted amount of weight produced according to the model B, geometric progression one. Okay, that's it. Okay, next is part C. What they have asked in part C: calculate according to the two models difference between the total amounts of weight produced to be produced weight predicted to be produced on the farm from year 1 to year 12 inclusive. That means year 1 till year 12 it's inclusive. That is the 12th year is inclusive. Give your answer to the nearest 10 tons. Okay. So total amounts of weight produced in 12 years. Okay. So we need to find out the total amount of weight produced according to model A at first, and then we will consider model B, and then we will find out the difference. So model A, total amount, it's what? Model A is an arithmetic progression. So in that case, what's the formula for summation of first 12 terms? This is what? S of 12 equals to n over 2 times what? twice of A, which is 600, twice of A plus n minus 1 times D. D was 3700 over 11 as far I remember from the previous parts. Yeah, exactly. So 3700 plus 600 times 12 over 2, this is 6. So this is basically 25,800 what tons. Okay. Now prediction according to model B. You don't need to write total amount. You can directly write as of 12. That's enough. So for geometric progression, what's the formula for sum of the first 12 terms? This is what? At first, consider the value for r. The value for r, we got 40 over 3 to the power 1 over 11, which is basically greater than 1. So that means a times 1, what? R to the power n minus 1. Yeah. So 40 over 3 to the power 1 over 11. R to the power n minus 1 is what? Uh, a times r to the power n, r to the power n minus 1. This is not in the power. R to the power n. Okay. So here, okay, I will write it in the power. So a times r to the power n. R to the power n is 12. So it will be 12 over 11. I consider the power directly with the power of 40 over 3, the common ratio, over r, which is 40 over 3 to the power 1 over 11 minus 1. So what would be the S of the sum of the first 12 terms? It will be what? 40 over 3 to the power what? 12 over 11 r to the power n, then minus 1 times 300 over 40 over 3 to the power what? R to the power n. N is 1 over, okay, n is 12. So 12 over 11. This should be 12 over 11. Okay, so 12 over 11 and then minus 1. Okay, so the value gives, it gives, okay, it gives 300. Okay, I think 300, but they said we should give to the nearest 10. So that means according to this model, the value should be in decimal. Okay, the formula is a r to the power n minus 1 divide r minus 1. Oh, r minus 1. So it should be 1, just 1. It was correct earlier. Okay, then made it wrong. Okay, so 40 over 3, okay, to the power 12 over 11 minus 1 times 300 over 40 over 3, 40 over 3 minus what? Minus 1. Or 40 over 3 to the power 1 over 11 minus 1. Okay, this is 17,935 and something. 17,935.20387. Okay, so the difference is how much? Which one is giving larger value? 25,800 minus 17,935 is saved in the calculator. So what you will get? 25,800 minus the answer, it gives 7864.796,128. So to the nearest 10 tons, the value should be 78 what? 60, isn't it? 7860 tons. Okay, 60 tons. Fine. So The difference between the S of predicted S of between model A and model B is 7860 tons, and that's what part C of question number 7 has asked for. That's it.